Hello guys, welcome to another video. Today we'll be starting a new playlist for Apache Arrow. Apache Arrow has gained lot of attraction in the market because of it in-memory columnar storage. Okay, like if you take Pandas, it's a row storage only. But and also it's not in memory. But if you take Spark, it's an in-memory, but it's again a row storage. So Apache Arrow is a in-memory columnar storage, and it processes the data in memory. That's why it has gained a lot of attraction. So let's check some introduction in this video, and in the next videos I'll be uploading more techniques using Apache Arrow. So now the first thing, if you see what is Apache Arrow. Apache Arrow is an open source project, and if you see, that's a language independent columnar memory format for flat and hierarchical data. So even if you have a CSV data or a JSON data for any kind of data, this Apache Arrow will store the data underneath in a columnar format only. It prints as a, when we print it, we get it in the row format only, but underneath it stores in the columnar format, and it's a memory processing. Okay, and to be aware, it's a single machine. It's not like a multi-node processing system like Spark. It's a single machine only, and it is compatible for all the modern CPUs. So why to use Apache Arrow? So these are the four benefits which I felt why to use Apache Arrow. One is performance benefit. The columnar format is ideal for analytics because it leverages the CPU cache. So in case if you take the Panda, the major disadvantage with Panda is because it's not in memory processing, and it many times when you have huge amount of data, it throws the out of memory exception, right? So here it stores the data in the columnar format, and as it stores the data in columnar format, when we have like huge analytics, and it is very ideal to process it in memory, okay, because it leverages the CPU cache. And now zero data copy exchange. What is zero data copy exchange? So Apache Arrow supports multiple languages. It can be Python, Java, R and all. If you store the Apache Arrow table using R, and again you can read the same table again with Python only. You don't need to do any kind of extra configurations and all. It's a language independent too. So with Arrow, data can be transferred between processes or even between different languages without copying, reducing overhead and improving the performance in memory intensive applications. Okay. So now if you see, Apache Arrow is a common language agnostic format that standards how data is represented in memory. As I said, like irrespective of any language, the way it stores the data is common across all the languages. This point explains that whether you store from a Python language, whether you store from a R language, whether you store from a Java language, doesn't matter. The storage format in Arrow will be the same, irrespective of any language, and you can store with one language and you can read in another language using another Apache Arrow language, because it supports multiple languages. And if you see, the columnar format isn't limited for flat data, it can naturally represent nested and hierarchical data. Like they say, like it is not limited to a table or data. We can even handle the JSON data as well using the Apache Arrow. So what are the key things to know about Apache Arrow? Like it's an open source and a community driven, and it has ecosystem integration. So Apache Arrow is being used along with Spark and Pandas, and not only with Spark and Pandas. Apache Arrow can be used in DuckDB, Dream.io and all these data engineering tools as well. If you see, Apache Arrow focus on modern hardware. The design of Arrow takes into account the architecture of modern CPUs. That's it. So if you see the last point, evolving standards. As data volumes and complexity grows, Arrow is constantly evolving to meet new challenges in data analytics and interoperability. That's it. And now if we check the few differences between the Apache Arrow and Spark and Apache Arrow and Pandas, these are the few things. So let's check with Pandas. Data interchangeable across languages. As I said, the same data can be read in and written in one language and again read and written in some other language. That's it. It is data interchangeable across language. But Python is specific to Pandas only. And if you see, the data is stored in the columnar in memory. And here it's a row and column based, right, in Pandas data frame. So now if you see interoperability, zero copy sharing between systems. See, as I said, you store the Apache Arrow table in somewhere, and again you can read that particular Apache Arrow table in any language you want. But here if you see, if you store the Pandas data frame somewhere, again you have to need the Pandas library only to read it. Again some other libraries can't read it. There are some extensions, Spark can read the Pandas data frame as well, but ideally not everything. If you see, the performance wise, optimized for CPU and cache efficiently, user friendly but less optimized here. And if you see use cases, high speed analytics, and this is for exploring. If you want to explore the data granularly, then we use pandas ideally, because like we can go in depth into the each row and column level and all in pandas to explore the data. But if you want to use for analytics purpose, the Apache Arrow suits better. That's it. Now if you see the differences with Spark, this is an in-memory data format and distributed processing engine. So Spark is like distributed across multiple nodes. Data is distributed across multiple nodes and processed. But this is just in-memory in a single node only. So if you see the zero copy in-memory exchange, data shuffling, in Spark the data shuffling happens. If you see, this is local, optimized for single node memory, scalable across multiple nodes, as I said. And if you see, it has like multiple language support, and this is like end-to-end analytics framework like the Spark. So these are the few differences which we need to be aware between Apache Arrow and Pandas and Apache Arrow and Spark. But Apache Arrow can be used inside the Spark as well. Inside the Spark code as well, we can use Apache Arrow in between. And inside the Pandas code as well, we can use Apache Arrow. That's it. This is just a textual information, and the points we need to be remember is like Apache Arrow is a columnar storage, an interoperable language. And when we see, it's in the structure format only when we print, but underneath it's in memory and the columnar storage. Those are the two main pointers which we need to be aware of. And now if I come and show you the very simple example, see, I'm using the Python arrow, which we call it as a PyArrow. Okay, we have like arrow with all the other languages as well. There are two data types we have in PyArrow. One is the table and the second is array. So let's see how we declare this. Similar to how we declare the NumPy array, here we have pa.array of the array and the type same array. So now if you see, using these arrays, we are creating a table, pa.table of all the arrays and then column names. That's it. Now when we print this, we'll get the table like this. That's it. There are two. One is array and another is table. That's it. Now you can write this table as well. If you see pa.write table, this one, and how do you want in a Parquet format? It's a columnar storage, right? So if you see, it has written in this columnar storage only. Now if you see birth.parquet, if you see this is the Parquet storage which we can't view, but this is how the data has been stored underneath as a Parquet format. You can even read that as well. If you see pq, see how we are writing import. We are just having the pq or Python arrow.parquet, right? pq.write table. Similarly, we have to read like pq.read table of this particular file name. That's it. We read the same table. And now in case if you want to store the data in multiple partitions, so if you see a PyArrow data set as ds, okay, so we have to use this particular module, ds.write data set. What is the table you want to write? The table name and the name of the folder and the format and how you need to partition on years, I am saying. That's it. This is how we write in the multiple partitions inside the folder save directory. If you see, this is how the data has been stored. Okay, the folder name, the partition by year. That's it. Now we can even read that as well. Again, ds, again it's the same ds.dataset, this directory, the format, and what is it partitioned. And if you know, you can just read it. So if you print the files, you got the files, and if you convert into .to table, we got the table. So these are the very basic stuff which I have shown using the PyArrow. And the next videos, I'll come up with the data types and more complex features in PyArrow. That's it. Thank you so much for watching.